Thermal conductors and insulators. Thermal conductors are those materials which allow heat to flow, and normally they are metals. In a solid, as we discussed in our previous class, heat is transferred by molecular kinetic energy. Molecules collide with each other and they are capable of transferring heat. So then what are thermal insulators which do not allow heat to flow? Like glass, water, plastic, rubber. These materials also contain air, fiberglass, plastic, foam. They are thermal insulators. So right under it, that examples of thermal insulators are, right under it, that examples of thermal insulators are glass, water, rubber. They are called thermal insulators. They have different possible structures. They have different possible structures like air trap materials, fiberglass, etc. These materials are capable of holding heat. So polystyrene is also a material, that is that white color packing, which is in our new machines. They always put it like that. The new machines come in that packing. Now, give the heading, experiments to compare thermal conductors. Give this heading. This is a famous experiment. There are three rods. Each rod contain a wax. Now we heat the rods with the same flame. Now the conductor which is better in transfer of heat will melt the wax first. So these are the three waxes, and you will turn on the burner, Bunsen. You will lit the burner, and you will switch on the clock. The rod which will lose the wax first will be the best conductor of heat. Now you have to copy this screen. So the rod which will lose the wax first will be the best conductor. So you write under it, So the rod which will lose the wax first, you are just like you are burning water, and interestingly, there are some ice cubes in the lower part of the tube, but ice does not melt immediately because water is a very poor conductor of heat. Water is a very poor conductor of heat. Now, give a heading, everyday examples of thermal conduction.
Done.
All metals are good conductors of heat. So the cooking pans, kettles, electric iron are made of copper. Plastic and wood are poor conductors. So the handles of these apparatus, our cooking pans, utensils, are made of plastic. Okay, right under it, giving the example number 1, cooking pans, cooking utensils. Cooking utensils are made of metals. Cooking utensils are made of metal, while their handles are made of plastic and wood. While their handles are made of plastic and wood. Trapped air. Trapped air is a very good insulator. They trap air in double glazed windows of aeroplanes and many other materials like fur of animal, our special suits for winter which contain fur, they trap air. Now you have to give the heading convection. This is a new heading. Give a heading convection.
Done.
Convection can occur in fluid like liquid and gas. You have to copy this.
Done. Is it that the hot air rises and cool air sink in the
Like air conditioners, hot air rises, cold air sinks. When there is a temperature difference, density difference comes, and this moves the mass. Like hot water comes from the geyser. So hot fluid rises, cold fluid sinks. When we run air conditioner, split air conditioner, it is on the roof, it is near the roof, and cold air sinks. It's a cycle. This is called convection. You have to copy this. To give a new heading, no, just a so first write under it. In convection, mass moves. In conduction, mass does not move, but in convection, mass moves. You have to copy this.
I've copied.
Experiments to compare thermal convection. So like this is a common experiment. You have a beaker full of water, you heat it from one side, you put some crystal in it. When you put some colored crystal in it, you will see the crystals moving in a cycle. This is called convectional. This is called convectional current. So actually convectional current is like establishing a cycle. It's a cycle of heat and mass moves with the heat. Experiment, a very short but very
Convection can be demonstrated by placing crystals of coloured dye in water and then heating the water from below. Where the water is heated, the molecules become less dense and begin to rise. The dye shows the movement of the current of molecules as it first rises, then falls, transferring heat energy throughout the flask.
Now copy this heading.
I've copied it.
So this experiment is very famous and you have to copy this screen now. Convection, convection is always vertical, not sideways. So convection occurs either upward or downward, but it is not, sideways. You have to copy this, a very important concept. Everyday examples of thermal convection. You have to copy this screen. Now give this heading.
And
So in the daytime, look in the daytime, what happened in the daytime? Hot air rises and cold air sinks. This is a very famous example. In the daytime, hot air rises and cold air sinks. This happens in the daytime, and this is how nature controls the environment. Then there is a concept of land breeze and sea breeze. When it is the when ground and sea water are in contact, sea water has a higher value of specific heat capacity. So sea water does not heat up or does not cool down immediately. Ground always heat up and cool down quickly. So in the daytime, air moves from the sea to the ground to cool it, and in the night, reverse occurs. Air moves from the land to the sea to compensate for temperature. So you have to now give the, you have given, so write number one, movement of air in the daytime. Number one, movement of air in the daytime. Number two, land breeze and sea breeze. Number three, hot water systems like geysers, solar panels, they work on this concept of convection. Number three, hot water systems. Number four, refrigerator. We normally call it fridge in our house, but it is actually refrigerator. The freezer compartment denses air and it goes down, and it is a cycle. Then you have to write number five, air conditioner.
is it under the heading of everyday experiment of thermal convection?
No, it's all coming under the title of this heading. Na? We gave this heading, na? Numbering after that.
Yes.
Examples of thermal convection. Number five, air conditioner. These are called split air conditioner. Cold air sinks and hot air rises. Number six, room heating. Heaters are their favorite topic and they live in colder areas, so they need always room heating. So number six, room heating. The heaters are mounted on the floor and the hot air rises, so the room gets comfortable and the cold air sinks. This is the cycle of a room heater. So number six, room heating, and then copy this screen.
Okay. Done.
Now give the heading radiation.
Done.
So it is a mode of heat transfer in which heat is transmitted by electromagnetic waves. So write under it that mode of heat transfer by electromagnetic waves like infrared rays. So these are the this is the mode of heat transfer. This is the mode of heat transfer which actually occurs by electromagnetic waves. Now, electromagnetic waves actually are able to travel without any medium. They can travel through anything, and they can travel through space also. So these rays are capable of traveling through everything, including space. So they are the waves which are capable of traveling through all the types of medium. This process does not need any medium. Why it does not need any medium? Because electromagnetic waves are able to travel through everything. You have to copy this screen.
Done.
So for example, for example, heat is coming from the sun to the earth and heat is traveling through space. So you have to copy this example. Thermal radiations can be infrared, they can be ultraviolet. The difference is there that ultraviolet have shorter frequency and infrared have a longer frequency. They both are invisible to us. So they can transfer through anything, the electromagnetic waves. Thermal radiations are reflected from a shiny surface like a mirror. So right under it, that thermal radiations bounce back. Thermal radiations bounce back from a reflecting surface like a mirror, from a reflecting surface like a mirror. Now you have to copy this screen.
That
Emitters, emitters and absorbers of thermal radiations. Have to give this heading.
yes.
Now, surfaces are, there are three types of surfaces: good absorbers, good emitters, dark objects are there. Poor absorbers are poor emitters, light color objects, and reflectors are shiny surfaces. You must have seen that famous reflector
Yes.
put in our car for when we park it in sunlight. And also reflectors are, many other options are there. You have to copy this screen.
Done.
So what is the theory? That good emitters of thermal radiation are also good absorbers. Good emitters are good absorber, while like a black color, while poor absorbers are poor emitters. White and silver color are bad absorber, and so they are bad emitter. So when we make a point of view here, like black colors are good absorber and good emitter, silver are reflector, white are white are poor absorber and poor emitter. Now give the heading effect of surface.
Done.
We see the color, we see the texture, and then we decide that this object will emit it. So you have to copy this screen.
Done.
Now, rate of emission of radiation. Rate of emission of radiation depends on the surface temperature and the surface area of an object. For example, coal which we use in barbecue, the coal which we use in barbecue, we first heat it, and then we allow it to release heat. Now, this is an example of emission rates. Some objects emit heat very quickly, like coal and other radiation substances. Some substances emits heat slowly. Like you must have observed that if you are living in a home, the roof of the home is always at a higher temperature. In the night time, that roof begins to radiate heat. In the daytime, it was absorbing heat, but in the night time, it is releasing heat. Some people who are living at the highest floor, they always have a problem of heat from the roof. So rate of emission of radiation, you have to copy this screen, give this
Done.
heading, and then you have to copy this.
Done.
Experiments to compare thermal radiation, give the heading. Experiments to compare
Done.
Now, these are some famous experiments which they give in the paper, how we can compare. Like put hot water into 2 cans, cover both the cans and put thermometer in each can. Keep both cans where they were, no sunlight. Like these are the 2 cans and we have a temperature graph with it. So we are going to compare cooling, for example. Now these are the two, these are the 2 cans, and we have put a thermometer in both of them, and we have put water in them. So this is a common experiment which comes in the paper. It's a comparison. It is a comparison experiment. So you have to copy this screen.
Do I need to learn how to draw these beakers?
You should learn how to draw basic diagrams like this. Complete it. I'm just coming.
Okay.
Now the cans can be in different models like shiny covered, dark covered, or white covered, painted, and dark covered, painted. So we can use the same experiment for different purposes, and we can compare the temperature fall in the case. Now you have to update the same diagram.
I've copied it.
Look at the graphs. The temperature is decreasing in both diagrams. The temperature is decreasing and they will eventually reach the room temperature. The same experiment can be conducted for different cases. For example, we can use matte black surface with white painted surface. We can compare them, insulation in between. We have to put the same volume of water. One apparatus can be used. One apparatus can be used for a number of trials, matte black and shiny silver surface. So the graphs are like this. Gradient is equal to rate of change of temperature. So what are we doing actually? We want to compare the rate of cooling in the two cans. Now give a new heading, consequences of thermal energy transfer.
Done.
Now there are two important consequences. Sometimes we want to get rid of heat. Sometimes we want to get rid of it like in a kitchen. And sometimes we want to hold the heat. We do not allow the heat to enter like in an air-conditioned room. You have to copy this.
Done.
Conduction occurs in solids only. Convection occurs in fluids only. Radiation occurs virtually everywhere. So this is a summary, a very important summary. How we differentiate between them. You have to copy this.
Done.
Convection occurs upward or downward only. Radiation occurs in all possible directions. Convection occurs only in the vertical direction, while radiation can occur in all possible directions. You have to copy this also.
Done.
Now, this is, for example, a heater. Radiation is traveling straight towards the metal plate. When it touches the metal, conduction will occur and wax will melt. Convection doesn't reach sideways, so convection is not shown. Heating objects such as kitchen pans, you can see the handles and the metals are there. So in the metal, conduction occurred. And from the stove, these are the new stove which you have seen when there is a gas shortage in our country. People use this infrared. You must have seen it or you will see them soon. That these are infrared stoves which radiate heat. Then heating the room by convection, which is another example. Measuring temperature. These are those famous infrared thermometer. When it was COVID, they were common. And using the thermal insulation to maintain the temperature of a liquid, like the cover, like we put a vacuum, we put a lid, shiny surface and insulation cover. Like we provide insulation for our homes so that thick curtains like loft and underfloor insulating, double and triple glazing of windows, our purpose is to stop heat transfer. Similarly, the polystyrene cups in which we take the liquid, then the famous thermos. Thermos has a shiny surface and a vacuum and a plastic casing, so it stops heat transfer. So these are the methods which we use for, these are the common applications. Now you had written that, so write under it. For example, thermos. Actually, thermos is not a good word. Better write vacuum flask. So write under it, for example, vacuum flask.
Done.
Vacuum flask, comma, infrared stoves, infrared stove, infrared thermometers, now discuss the methods of heat transfer. So now give the heading methods of heat transfer, where we want to promote the heat transfer. We want heat to get out. Ventilation, black painted metallic fans, exhaust fans, evaporation. They support the heat loss. You have to copy this.
Done.
So this is the end of the chapter, and we will start inshallah waves tomorrow, which is our last section. And you need pencil and ruler for that. And we stop here, and we will inshallah continue in our next class. Allah Hafiz.